So now we're going to shift to some new terrain. We're going to move from ancient Buddhist thought to modern psychology. And by modern psychology, I mean psychology starting roughly in the second half of the 20th century. But we're going to stay focused on something that we were looking at in the context of Buddhist thought, which is what to make of this thing that we call the self. What, if anything, it is. And we're going to see some experimental evidence that the thing we think of as the self, the conscious me, the thing I think of as running the show, may not be running as much of the show as we think it is. We may be attributing more power to it than it really deserves. Now, in a way, this idea goes back to pre-modern psychology because, of course, Sigmund Freud became famous for saying that, our behavior is actually controlled to a considerable extent by all these unconscious forces, and the conscious mind isn't as in charge as we think it is. So broadly speaking, you could say that the experimental evidence we're about to see is an affirmation of a Freudian worldview. But I want to emphasize broadly speaking, because when you look at specific ideas that Freud came up with about how exactly the unconscious mind influences the conscious mind in behavior and what the dynamics of that are, some of those ideas don't look very good in light of modern thought. And also, though Freud was very skeptical about the power of the self, some psychologists today would say he really wasn't quite skeptical enough. Freud had basically a three-part model of the mind. There was the id, which harbors these dark animal impulses. There was what he called the superego, which corresponds more or less to the conscience. And then in the middle of things was the ego, the self. And it's true that he emphasized that the self isn't as in charge as it thinks it is, but he did put it right there in the middle, and he did attribute some autonomy to it, some independent power to it. And there are psychologists who, especially in light of some of the experiments we're going to look at, would say that even that model gives kind of too much credit to the self. And some of these psychologists are working on a model of the mind, which we'll come to, which really has no place for the self at all. Okay, now in the kind of modern history of doubt about the power of the self, there's one set of experiments that really are kind of a landmark. And these are known as the split brain experiments. You may well have heard of them, especially if you've taken an introductory psychology course. They've gotten a certain amount of publicity, and they're certainly very memorable because, in a way, they have some very strange results. Now, these experiments involve people whose hemispheres, the two halves of their brains, had been disconnected. Most of us have something called the corpus callosum, a bundle of fibers that connects the two halves of the brain. But these people had theirs surgically severed, in most cases to control seizures. And when this procedure was first done, it seemed kind of miraculous because it didn't seem to have much effect on behavior aside from controlling the seizures, which is kind of surprising. You'd think that something connecting the two halves of the brain is this really important thing. Who knows what will happen if it gets cut? Well, not much noticeable happened. But then in the 1960s, some researchers, in particular Michael Gazzaniga, came up with a kind of experimental apparatus that got split brain patients to behave in some pretty strange ways. Now, to understand what he did, you have to understand, first of all, that the way the brain works, information in the left half of the visual field enters the right hemisphere, and information on the right half of the visual field enters the left hemisphere. I don't know why natural selection did it that way. I don't think I would have, but that's the way we're set up. So it's possible, if the two halves aren't connected, as in these patients, to put information in one side of the brain that just stays there and doesn't go to the other side. So, for example, one kind of thing they did is they would flash a word like nut in the left half of the visual field, which means it entered the right half of the visual field, of the hemisphere, the right hemisphere. And the way they could tell that it didn't get to the left hemisphere is they would say to the patient, "What word do you see?" And the patient would say, "I don't see a word." Now, here's the explanation for that. In most people, it's the left hemisphere that houses the language faculties. So that's the half of the brain that does the talking. So that's the half of the brain that was reporting that it saw nothing. But they had a way of determining that the word nut had made it into the right hemisphere, because the right hemisphere controls the left hand just as the left hemisphere controls the right hand. And they found that if they let the patient rummage through a box of objects, the left hand would seize upon a nut. Okay? Even though you ask the patient, what word do you see? The patient says, I don't see a word. There clearly is somewhere the presence of that word registers and then in turn motivates a behavior, the seizing of the nut. Now this is kind of strange when you think about it, because, you know, ordinarily if a word enters your brain, it enters this conscious field, and if it influences you to do something, you think of yourself as deciding to kind of do something in response to the information, and you can share the information with the world, right? You can talk about what you've seen. In this case, that's not what's going on. The person can't talk about the information, and the person seems to be not conscious. But here, not conscious of the information. But here we have to be careful, because we really have no way of knowing that the right brain is not itself conscious. We know that the conscious left half of the brain didn't see the word, but there's no way for that half of the brain to know whether the right brain is actually experiencing things subjectively, and the right brain can't say. So we don't really know. And it's funny, people have different intuitions about this. Some people tend to say, well, of course it's conscious. The right brain is going to be conscious. It was conscious before they cut the brain in half, right? So naturally, there's going to be some consciousness there. Other people find it weird, almost creepy, to think that, you know, if you're identifying with the left half of the brain, you're the thing that does the talking, as usual. To think that there's somewhere in your body some conscious being that you can't communicate with inhabiting the same body, that strikes some people as very strange and very paradoxical. Okay, there's a second finding from these split brain experiments that adds a kind of a second dimension of strangeness. If you flash an instruction on the left visual field so it enters the right brain, like you say walk, the person will follow it, the person will get up and walk, and then if you ask the person, where are you going? Remember, the answer is going to come from the left brain, which doesn't know the correct answer as to why it got up and started walking. And the left brain tends to come up with an answer. The person will say something like, oh, I'm going to get a soda, and apparently will believe it. That is, the left brain will believe the story, even though it was fabricated on the spot. And that's kind of strange when you think about it. Then there's a third finding that is a little more complicated than these first two. This involves kind of both halves of the brain at the same time in both hands. So what they did was they presented to the left hemisphere the image of a chicken claw, and the right hemisphere saw a picture of a kind of a wintry scene with a lot of snow. And then they let both hands choose from among a number of pictures. And the hand associated with the left hemisphere, which had seen the chicken claw, chose a chicken, obviously, reasonably enough. And the hand associated with the right hemisphere, which had seen the winter scene, the snowy scene, chose a snow shovel, which also makes sense. And then they asked the person, okay, why did you make these choices? And remember, the answer's coming from the left brain. And the person first says, well, the chicken claw goes with the chicken, and that's, the left brain knew both of those things, knew about the chicken and the chicken claw. And then the person looks down at his hands and sees that one of the hands, unbeknownst to the left hemisphere, has chosen a shovel and says, well, you need a shovel to clean out the chicken shed. So the person came up with this story that makes sense. It's coherent. It's just not true. Okay, so what's the main takeaway from that set of experiments? I would say two basic things. First of all, those experiments suggest, but don't prove by any means, that the conscious self is capable of greatly overestimating the amount of influence it's exerting on behavior. Secondly, the experiments suggest, but again don't prove, that the conscious self can promulgate and apparently believe wildly untrue stories about the actual motivation of the person. Now, the reason I say suggest but not prove is that, remember, these were not anatomically normal people. So we're not really seeing the conscious self work as it's normally wired. The findings are certainly very suggestive, but it's hard to conclude much with confidence about the self as it normally exists. The most we can say is that this left hemisphere, which some people do think is the seat of consciousness and does seem to be the seat of language, at least in most people, that is capable of these kinds of delusions, at least when it is severed from the rest of the brain. So how can we study anatomically normal people? Well, it's harder to come up with such exotic results as we saw in the split brain experiments, but psychologists have managed to establish that people are sometimes not conscious of the actual motivation of their behavior, and that they may actually kind of come up with stories about the actual motivation when they don't know the real motivation. So a kind of classic in this field is a study that was done several decades ago by Richard Nisbet and Timothy Wilson. It involved pantyhose, 4 pair of pantyhose, that were arrayed in front of people for them to examine the way a shopper would examine pantyhose. And one thing they found is that people had a strong tendency to choose, when asked which was their favorite pair of pantyhose, to choose the pair on the far right. For whatever reason, people tend to do that in that kind of setup. The people weren't aware that that was influencing their judgment, because when they were asked, well, why did you make this choice? All the people who had chosen the one on the far right didn't say, well, because it's the one on the far right. They came up with other reasons. They would talk about the texture of the pantyhose, or, I like the way it's slightly more opaque than the other pantyhose. But in fact, all the pantyhose were identical. They were the same brand, same model. So, the subjects hadn't been told this, but clearly these people were kind of straining to come up with a reason for having done what they had done for a reason they didn't understand. Now, a lot of experimentation has been done on unconscious motivation, or motivation that we're not aware of, using subliminal techniques. That is, presenting information in a way that does not enter the conscious mind, but still does influence behavior. Typically, you would flash the information so briefly on a screen, say, that the person is not aware of having seen it, but sometimes it does influence behavior. One study in particular that I think is worth talking about. Now, subjects were brought in, and they were told, here's a hand grip. The harder you squeeze it, the more money you're going to make. And on each trial, it will be randomly determined whether what you earned, whether the maximum payoff was a penny or a pound. This is in England, okay? So it's a penny or a pound. Pound is, of course, a whole lot more than a penny. Now, as the subjects looked at the computer screen, where they were going to see a gauge of how forcefully they were squeezing the grip, before they gripped the grip, a pattern appeared on the screen. It was just a kind of abstract circular pattern for a fraction of a second, but long enough to see. And then that would be replaced in the same circumference by an image of a coin. It would be either a penny or pound. And then that would be replaced, again, by the pattern that was initially there. So the image of the coin was sandwiched in between the two appearances of this pattern, and in some of the trials, it was done subliminally. The coin was shown so briefly that there was no conscious awareness of having seen the coin. What they found in those cases is that even when people weren't aware of having seen the coin, when the pound was shown, the people did tend to squeeze the grip harder. So first of all, there was that influence. Again, evidence that unconscious things we're not aware of can influence our motivation. But there was another interesting dimension to this study, because it was a brain scan study, and they were scanning a part of the brain that's associated with motivation and emotion. And they found two things. First of all, they found that when they did leave the coin up there long enough for it to enter consciousness, so that people were actually aware of whether they had seen a penny or a pound, then what they found in this brain region was that it got more active when a pound was shown than when a penny was shown. Okay, this is when they're actually conscious of seeing the coin, and they did squeeze harder in the case of seeing the pound. What's interesting to me is they found the same asymmetry in the case of the subliminal presentation of the coin. So when people aren't aware of having seen the coin, they aren't consciously aware of it, that same brain region shows that asymmetry. That is, when the pound is shown, there's more activity in that brain region than when the penny is shown. Now what this suggests, and this is just one interpretation, but it's plausible and interesting, is that maybe, the conscious perception just doesn't matter at all in a situation like this. In other words, the real motivational action is happening there in the physical brain, and the more activated this particular region gets, the harder the person is going to squeeze the grip. This region gets activated, sends a signal to squeeze the grip, and in some cases the person becomes conscious of the activity in the brain because it's that strong or it lasts that long or whatever, and in those cases the person may kind of, in a sense, become aware of the motivation and even own it. The person may say, and I don't know if, in this experiment they didn't ask this question apparently, but the person could conceivably say, well, I felt, when I saw the coin, I obviously decided to squeeze harder. I felt motivated, so I squeezed harder. But maybe the conscious experience of seeing the coin actually didn't add anything to the motivation at all, and all the action is in the strictly physical machine. This interpretation of the findings is not one that the authors of the paper themselves put forward. They did emphasize that, as they put it, consistently the same basal forebrain region underpinned subliminal and conscious motivation. But they didn't get into the various possible interpretations of that really interesting fact. Now, before we finish up this lecture, I want to bring up one more finding from the split brain stuff. There's a kind of experiment you can do with people where you show them like dozens of pictures, and the pictures tell a kind of coherent story, like guy gets up in the morning, gets ready to go to work, goes to work, and then you show them a second bunch of pictures, including a lot of the ones you showed them the first time, but also including some other ones. And you ask them, with each picture, was this in the original group? Did we show you this the first time around? And there's two kinds of new pictures that have been added to the series. One is pictures that weren't shown to the person but make sense and fit into that plot line. So it would be a different picture of the same guy getting ready to go to work, or a different picture of him driving to work or something. And then there are also pictures that don't make any sense in terms of the narrative. The guy's out playing golf, he's going to the zoo, or something like that. Now, what happens with anatomically normal people whose brain hemispheres are still connected is they say, the pictures that are obviously don't fit, they easily reject. No, he wasn't at the zoo. No, he wasn't playing golf. But a fair number of the pictures that make narrative sense, that fit into the storyline, they'll say, yeah, I saw that, even though they in fact didn't. Now, when they do this with split brain patients, they find that the left brain does that same thing, does what an anatomically normal person would do. But when they show these pictures to the right brain and then have the right brain kind of discard pictures in the second round that weren't part of the first round, what they find is that the right brain is, strictly accurate. It not only discards the pictures that obviously don't fit, it also discards the pictures that make narrative sense but weren't part of the original series of pictures. So what this suggests is, first of all, the right brain is about literal truth and detailed orientation. It sees the trees, but not necessarily the forest. Whereas the left brain is more about kind of the gist of the story, the overall plot line, and it may even be willing to live with a certain amount of embellishment if the embellishment fits the story. And that makes sense in a way because the left brain is, after all, responsible for telling stories to the world. It generates the language. It's the part of the brain that is going to say, well, I saw a guy, he got up, he went to work, and so on. And the main thing is that you get the storyline more or less right, and it's coherent. That's much more important than paying attention to every single detail as you observe the guy. The main thing is to have a story to tell. That's more or less true. Okay? And so in that sense, it makes sense that the left brain focuses on the overall plot line. But remember, the left brain doesn't just tell stories about other people, about a guy who got up and went to work. The left brain also tells stories about ourselves to the world. It does kind of the presentation of ourselves to the world through what it says about us and what it says that implicitly reflects upon us. And, we've already discovered that the left brain is capable of, apparently, of buying into massive fabrications. So, it's worth exploring a little more what kinds of stories in anatomically normal people we do tell about ourselves and how true they are or are not. And in the next lecture, we're going to do some of that. We're going to look at our presentation of ourselves, the stories we tell about ourselves, how true are they or aren't they. And it's going to turn out that subject ties into a much larger subject that we're going to spend most of the next lecture on. And that subject is this emerging theory of the mind that I alluded to earlier, that a growing number of psychologists are buying into. And this is a theory of mind called the modular theory of the mind. And some versions of it have no place at all for the self, at least not in anything like the way we've normally conceived of the self. So, if you ask the question, well, wait, if the Buddhists are right, there are deeds, but there is no doer. There are thoughts, but there is no thinker. Then how do the deeds get done? What decides what deeds get done? How do the thoughts get generated? Well, the theory we're going to talk about in the next lecture is the best candidate I'm aware of in modern psychology for answering that question. So I'll see you next time.